All right, we're going to be looking at 7.1.2, which is the 7th grade textbook, Chapter 1, Lesson 2, Complex Fractions and Unit Rates. It starts on page 17. So what I would like for you to do is on the top of your paper, please write 7.1.2, Complex Fractions and Unit Rates, and page 17. If you need to pause the video to continue writing, do so now. Alright, so we're looking at the real world link where it says that Dana is skating laps to train for a speed skating competition. She can skate 1 lap in 40 seconds. I want you to answer 1 through 3, and we're going to come back and talk about 4, but you can attempt to do 4 as well if you'd like. Go ahead and pause the video now and work on your own. Alright, so what would have been a good idea is for you to have written out the story here that Dana is skating the laps to train. And then you could have written the ratio here, as well as this 1/2 lap in 20 seconds. When we're writing the ratio of her time for exercise 2, writing it with time over laps would be 20 over 1/2. Since she did 20 seconds, she did 1/2 a lap. So how could you simplify the ratio that you wrote for exercise 3? And we're going to see a definition for that in just a moment. But basically they're wanting us to divide the 20 divided by 1/2 so that we come up with whole number integers, that we're not dealing with fractions in a fraction. Alright, so here's our vocab. So go ahead and write vocab. And then I'd like for you to copy down the vocab for complex fractions. So it says simplify complex fractions. Fractions are like 20 over 1/2 are called complex fractions. Complex fractions are fractions with a numerator and denominator, or both, that are also fractions. And so you could then do an example and say an example would be 20 over 1/2. The other thing I'd like for you to also put down is simplifying complex fractions. So simplifying complex fractions, and I want you to write is when both the numerator and denominator are integers. So you're going to do whatever you have to do to be able to make both the numerator and the denominator into a whole number. If you need to pause this more, please do so and copy that down. Now we're moving on to example number 1. So I'd like for you to put example number 1 and then write simplify 1/4 over 2. So we have 1/4 over 2. We're going to write that out as a division problem. So you see that the first thing that we're going to do is write the complex fraction as a division problem. So step 1, and you're going to write this right here. Write the complex fraction as a division problem. Next to that, you're going to go ahead and write out the 1/4 divided by 2. The step 2 that we need to write in, and again, pause whenever I'm going too fast because you've got more to write down than I am. We're going to say multiply by the reciprocal. Okay, multiply by the reciprocal. So that's the KCF. Do you guys remember KCF? Or you can call it KFC if you want to remember it. So we're going to keep the first, change the sign to multiplication, and flip the second. That's multiplying by the reciprocal, because reciprocals are when we flip it. So we now have, oops, and I didn't do the reciprocal. We now have 1/4 times 1/2, because we need to multiply by the reciprocal. 2 would be 2 over 1, flip-flop it, and there you go, 2 over 1, or 1 over 2 now. So 1/4 times 1/12, or 1 second, I don't know what's wrong with me, 1/2. Anyway, 1 times 1 when we do our hamburger is 1, and then 4 times 2 is 8. So the answer to simplifying 1/4 to 2, a ratio of 1/4 to 2, would be 1/8. Because our 1 is a whole number and our 8 is a whole number. So now we have a normal looking fraction. We no longer have a complex fraction. So again, over here it says dividing by fractions. First write as a fraction with a denominator of 1, then multiply by the reciprocal. You can copy this little note down with the example here where 1/4 divided by 2 can be written as 1/4 divided by 2 over 1. And then we do our KCF. Alright, next thing. Now you're going to write example number 2, and you're going to write simplify 1 over 1/2. And again, we're going to rewrite the complex fraction as a division problem. So we're doing step 1 again. We're going to do 1 divided by 1/2. It goes in this order, 1 divided by 1/2. All right, now the second step is to multiply by the reciprocal. So multiply by the reciprocal is going to be 1 times 2 over 1. So I do keep, change, flip. So I'm going to keep the first, change the second, flip the second, and now we're just doing hamburger. And if you want to write down step 3 as hamburger, please do so. You can also cross simplify if there's anything available, which in these last 2 examples there hasn't been. And so 2 over 1 or 2, if we're talking about a ratio, you would leave it as 2 over 1. If we were just doing a complex fraction and simplifying it, which is what the directions here say, then 2 is fine as an answer. If it's a ratio, though, remember we have to have a top number and a bottom number. All right, now you're doing A, B, C, and D on your own. I went ahead and copied here the step-by-step way to go. So if you need to rewrite that down before you start writing these out, or for each one, that's completely up to you. But you're doing A, B, C, and D on your own. When you come back, I'll have them written out. All right, so here is A. We had 2 divided by 2/3. So the first thing I did was write the complex fraction as a division problem. And then the next is multiply by the reciprocal. So I'm going to do 2 times 2/3 is now 3/2. I'm going to go ahead and put my whole number as a fraction over 2 so I can do my hamburger. Hopefully you see that you can cross simplify. Both your 2's can be divided by 2. And so now I have 1 over 1 times 3 over 1, which when you do hamburger is 3 over 1 or 3. Now B, again, we're going to write the complex fraction as a division problem. So it's going to be 6 divided by 1/3, which would be rewritten as 6 over 1 times the reciprocal, which is 3 over 1. There's no simplifying to be done, so I'm just going to do my hamburger and multiply, and you should end up with 18 over 1 or 18 for B. C is written as 2/3 divided by 7, and change to 7 over 1. I'm going to do my KCF, or multiply times the reciprocal, which is going to end up being 2/3 times 1 over 7. When I do my hamburger, because there's no cross simplifying to do, I end up with 2 over 21, which is my final answer. So 2 over 21 is the answer to C. D is going to be 2/4 divided by 2. Go ahead and make that into a fraction over 1. We're going to keep, change, flip. You might notice here that we can cross simplify our 2's, and we end up with 1 times 1 over 4 times 1, which is 1/4, which is the final answer for D. So that's how you would simplify these complex fractions. All right, the next one we're going to do is find unit rates, and again, this is familiar, but now we're going to be dealing with some fractions, I'm sure. This is when the fractions of a complex fractions represent different units, you can find the unit rate. So go ahead and title this section Find Unit Rates. And we're going to do example 3. Of course, I don't want you to write down this whole thing unless you'd like to, but it says Josiah can jog 1 1/3 miles in 1/4 hour. Find his average speed in miles per hour. So we're going to put the miles on top, which is the 1 1/3, and the hours on the bottom, which is 1/4. But we want to know how much it is miles per hour. So to correct this from being a crazy looking complex fraction, we're going to make this into, we're going to simplify it into a, sorry, my mind's wandering because I'm thinking that should be something else, but okay. We're going to go ahead and make this into a simplified fraction so it's no longer a complex fraction. So we take our 1 and 1/3 divided by 1/4, and we write out our division problem. Then we do our keep, change, flip. Actually, let's go ahead and first change this to a improper fraction so we can get rid of our mixed number. So that's going to be mad, multiply, then add, and then over the denominator. And then we can change this to multiplication. Oh, I ran out of room there. Hold on. Multiplication with the reciprocal, and that will end up being 16/3. 16/3. Okay, my threes are not going to happen here. Now, that's still not, that's saying 16 miles in 3 hours. That's still not telling them how many they're doing in 1 hour. So we take that 16/3, and if I want to make it into 1 hour on the bottom, which is what the unit rate would be, I'm going to have to divide top and bottom by 3. And if you do 16 divided by 3, you're going to end up with 5 and 1/3. So 5 and 1/3 miles per 1 hour. So it started out with 1/4 of an hour, but now we still have a complex fraction, but it is at least for 1 hour now. So 5 and 1/3 miles in 1 hour. So I guess it really depends on what they're asking. They're not asking for you to simplify the complex fraction. They are asking for you to find the average speed in miles per hour, which means 1 hour, and that's what we've done here with our 1 hour as our denominator. Okay, and when we write it out, it would be written as 5 and 1/3 miles per hour. Now, if they said to fix that, the best we could do is say 16 miles in 3 hours. If they wanted to simplify it so that there were no longer any complex fractions. All right, now do example number 4. That didn't work out. All right, Tia is painting her house. She paints 34.5 square feet in 3/4 hours. At this rate, how many square feet can she paint each hour? So we want to know again how much we're painting per 1 hour. So we're going to set this up as 34.5 over 3/4, which we're now going to write as a division problem. 34.5 divided by 3/4. We're going to make this an improper fraction, which is what, 68 plus 1 is 69 over 2 divided by 3/4. We're going to keep, change, and flip. We can simplify here with our 69 and our 3. This will become 1, and this will become 23. The 4 and the 2 can also be simplified. So that will be a 2 and a 1 now. And so now I'm doing 23. I'm just going to rewrite it because it's a little crazy over there. 23 over 1 times 2 over 1, which is going to be 46 over 1. So 46 feet squared in 1 hour. Because we're looking for that denominator.